Welcome to another physics class. In our last lesson, our topic is coefficients of friction in horizontal plane. And by then, we've done 5 examples based on the topic. And I promise when we end the lesson that today we are going to see more examples under the same topic. So for today now, since we've done 5 examples, let's take this one as example 6, is the continuation. And as I always say, if you are just joining us, please try to like, share, and subscribe so that our former video will be given to you and you'll be able to watch it and continue with us. Let's take this one as example 6, as I said. A bus of weight W is in equilibrium by action of two forces, 6 Newton and 8 Newton, in opposite direction. When the third force incline at 30 degrees to the vertical in same side of as 6 Newton, as 6 Newton force, calculate the weight W of the bus. Now, according to this question now, we need to put it in drawing so that we can understand better. Let's say this is the horizontal plane. Let's say this is the bus. According to the question says the weight is W not given. Now, a force on this side, 6 Newton, on the opposite side, 8 Newton. And another force, which is not known, is acting at an angle 30 degrees to the vertical. Let's say this is the force. That's the third force, 30 degrees to the vertical. Let's call it F. Now, the question now asks us to calculate the weight of this bus. Now, from this question now, we have two unknown, the third force and the weight of the box. Now, to calculate this one now, if you are familiar with what we have done in our previous lesson, this is the combination of both the horizontal force and the vertical force. So to solve this one now, we need to use both horizontal force and vertical force together. Now, for the horizontal force now, if you look at it, if you look at this force now, force F, we don't know the value and we must calculate the value. So if we say, let's say this is the direction of force F in horizontal direction, for this one, the same F in vertical direction, let's call it Y. This is Fs in horizontal direction. And because this F now is not a straight line. If it is a straight line like this, then we now consider it only as vertical component. But once it makes angle theta, so we need to consider it at both horizontal and vertical now. If that is the case now, for horizontal now, we call it Fs, for vertical, Fy. Now, the first thing we are going to do now, let's resolve horizontally. If we want to resolve horizontally now, then we need to take this one as horizontal force, our Fs also as horizontal force, then our 8 Newton as horizontal force. But the first thing we need to do now, we need to resolve this one into horizontal, this our F, because this is the direction of this F now, into horizontal component. So let's draw it. That triangle, this is our F, then this is Fs, and this is Fy. This is our F that we don't know. This is the angle made with vertical. Now from this one now, if you look at it, if you take this line and this FL and this angle, this is opposite and hypotenuse. So for horizontal now, we are going to have sine 30 degree be equal to Fs over F. That is opposite over hypotenuse. So then our Fs now, which is horizontal force now, be equal to F sine 30. That is when we resolve this one horizontally now. Now, if we resolve it horizontally now, look at the direction of the Fs, the direction of the Fs, the direction of the Fy. Because the question says the same side of 6 Newton, and this is 6 Newton. So it means the Fs and the 6 Newton are in the same side, facing the same direction, according to this our diagram. So now if you look at this horizontal component now, we have two forces here, the 6 Newton and the Fs. On this side, we have just 8 Newton. You can now say that resultant horizontal component force will now give us, that will be 6 plus Fs, that's F, okay, Fs equal to 8 Newton. Don't forget our formula. That will be 6 plus Fs equal to 8 Newton. Let me remind you, we said if it is only this 6 Newton and 8 Newton, it will be 6 minus 8, then is equal to 0, because the object is at rest. So then it will now be 6 is equal to 8. So apply this, what I've done now, to this one. Then it will be 6 plus Fs equal to 8. That's explanation under that one. So from here now, and our Fs is F sine 30. So we can now have 6 plus F sine 30 degree equal to 8. Let's calculate F here. So our F sine 30 degree will be equal to 8 minus 6. Now, it will now give us F sine 30 degree is equal to 2. Therefore, F now will be equal to 2 over sine 30. And sine 30 is 0.5. So F now will be equal to 2 over 0.5. So the answer for this one will be equal to, that will be 4 Newton. That's the value of F according to the question. Although the question is silent about the value of F, but without knowing the value of F, we won't be able to calculate the W. Now, for W now, let's now look at the same diagram. Since I said this F is not vertically at the same time. It's not only horizontally. We've resolved it horizontally the other time, and we get sine 30 degrees equal to fs over f. Now, let's now resolve it vertically now. Now say resolve f vertically. If we resolve f vertically as we resolve f horizontally here, then this plane will be adjacent, while this plane will be hypotenuse. That's so that we are going to have cos 30 degree is equal to adjacent over hypotenuse. That is Fy over F. Therefore, our Fy will be equal to F cos 30 degree. So therefore, we've resolved this one now vertically as we resolved the other term horizontally. Now, we can now say that the total vertical force now, the result as we said, this one resultant horizontal component force. The next thing now is to find resultant vertical component force. That one will now give us, that will be W, and mind you, W is going down, the vertical force is going up. So it will now be equal to W will be equal to Fy. Don't forget my explanation the other time. If it is only W, and let's say you have your normal reaction here, it will be R minus W equal 0. Apply that one. Our R will be equal to W. That's exactly what we have done here. Or W is equal to R. So if that is the case now, then, but our Fy now, W now will be equal to F cos 30 degree. Mind you, we calculated F the other time as 4 Newton. So our W now will be equal to 4 cos 30 degree. Now, from there, 4 cos 30, 4 cos 30, our W now will be equal to 4 multiplied by 0.866. That the answer will now give us 4 point. That will be 3.464 Newton. That's the weight of the bus according to the question. Let's take this one as example 7. A 3.5 kg mass sitting on a smooth surface is connected to a 5 kg mass, passes over a smooth pulley as shown in the diagram below. Find the acceleration of the body. That is the acceleration of the body is the diagram. Now, from this one now, as I said in the last question, this one also combines horizontal with vertical component. Now, to solve this one now, solution. When you look at the horizontal component now, this is tension, this is tension. The direction of the tension here is horizontal. So we can now say that for horizontal component, we can now say that F is equal to T, which is equal to MA. That is both the force and the tension here and the same thing. So we are going to have T now is equal to MA. And from here now, our M is given as 3.5. So our T now will be equal to 3.5A. Let's take this one as equation 1. Now, that is for T1. Now, that is for horizontal, for horizontal force. Now, to take it for vertical now, for vertical force, you consider this one and this one. So the weight of the body is moving down, the tension is going up, and it must be accelerate. So we are going to have W minus T2 then is equal to MA. If that is the case, do note the tension is T1 will be equal to T2. So if you stick to 1, you can now say but T1 is equal to T2 because it's the same string. So it will have the same tension. So if that is the case now, if you stick to 1 now, then we are going to have our W is equal to mg. And that will be, for this part, that will be 5 multiplied by 10 is equal to 50 Newton. So we are going to have 50 minus T. So we said T is equal to T1 is equal to T2, then is equal to, let's take anyone, equal minus T1 is equal to our M here is what? 5A. So let's take this one as equation 2. From equation 1 now, you can now say T1 is equal to 3.5A. And we said the tension will be the same at both sides. So that is why we said T1 is equal to T2 and we stick to T1. So if that is the case now, T1 is 3.5. Let's substitute 3.5A for T1 in 2. So we are going to have 50 minus 3.5A is equal to 5A. Now, that will be 50 will be equal to 5A plus 3.5A. 5A plus 3.5A. Then it will give us 50 is equal to, that will be 8.5A. 8.5A. Then A now, that is the acceleration of the body, will be equal to 50 divided by 8.5. And A will be equal to 5.882 meter per second square. That's the value of the acceleration of the body. Now, let's take this one as example 8. This one will be the last example under coefficients of friction in horizontal plane. Two particles of masses 10 kg and 8 kg are connected by a light inextensible string pass over light frictionless pulley, which is fixed to the ceiling, as shown in the diagram below. This is the diagram. Calculate the tension in the string, that is the tension T in the string, tension T. 2. Acceleration of the particle when released. And G is given as 10 meters per second square. So according to this diagram, let's look at it together. This one is basically on vertical motion only. But let's look at this side, 8 kg side. If you look at it, this 8 kg is moving up in the same direction of tension. Once it is moving up, then the equation for this one will be T for 8 kg mass. The equation will be, since the direction of the tension is up and the weight is following the direction, but the weight is acting downward. That is why I put the arrow like this. But it is being pulled up in the direction of this tension. So it will be T minus W is equal to MA. Why is it MA, not its log to zero? Because the particle is on motion. That is why the question says you calculate the acceleration. Now, from this one now, you can now say but W is equal to mg. And m on this side is C, that's 8 multiplied by 10. Then that is 80 Newton. So we are going to have T minus 80 is equal to m is 8. That is 8a. Call this one equation 1. Now, on the other side of this equation, of this diagram, which is for 10 kg now, for 10 kg mass. For 10 kg mass, look at it, the particle is coming down in the same direction of W. That is W2 for this one. This one is W1. And that is why we calculated as 80 Newton. Now for W2, this thing now, the particle of 10 kg is coming down, and the weight is coming down. So instead of saying T minus W2 now, it should be W2 minus T. That will be W2 minus T is equal to MA. Don't forget, here we said it should be T minus W1. Why? Because this particle is moving up and the weight is acting downward. Moving up and the tension is up. That is why tension minus W1. But here, the particle is coming down. W2 is down, but the tension is up. That is why, since this one is coming down, that is why W2 minus T equal to MA. And W2 here equal to mg. That is, the m here is 10. That's 10 multiplied by 10. That is 100 Newton. So therefore, we are going to have 100 Newton minus T is equal to, that is 10A. Because the 10 here is, the m there is 10. Now, mind you, if you call this one M1, so not confused, call this one M1. Our M1 is 8 here. And call this one M2. Our M2 here is 10. So that one is okay. So from there now, if you call this one equation 2 now, if you now look at equation 2 and equation 1 together, now equation 2 and equation 1. So from there now, we are going to have T here is, T can be, if you substitute for this one, so this one can be T will be equal to 8A plus 80. That is T Now, substitute this one for this one. Then we are going to substitute 8a plus 80 for t in 2. So we are going to have 100. What is our t here now? That is minus 8a plus 80, then is equal to 10a. Open the bracket now, since our t here is 8a plus 80. And we want to substitute for t here. Don't forget the minus. We have 80. That will be 100 minus 8a minus 80 is equal to 10a. From there now, collect the like times. That will be 100 minus 80 is equal to 10a plus 8a. So this one will now give us 20 is equal to 18a. Then a now will be equal to 20 over 18. Then a now will be equal to 1.111 meter per second square. That is for the acceleration. Now go back to the first question now. The first question says you calculate tension in the string, and the tension is T. So we can now go back to calculate one now. Once we know the value of A now, then we can now say if we want to use this one, that T is equal to 8A plus 80. Or you can use this one. Let's use this one, that T is equal to 8A plus 80. Since T is equal to 8A plus 80, then we can now say our A is 1.111, that is plus 80. Then this one will now give us 8.888 plus 80. Then the tension will be equal to 88.888 Newton. Now, this is convenient point to stop for today again. We've done the necessary calculation under coefficients of friction in horizontal plane, plus the one we've done in our former lesson now. This one will now make the 8th calculation that we have done now. And I believe for the calculation now we've done enough. But if you still have questions, either based on this topic or any other topic, you are free to ask your question from the link under the channel. And as I said earlier, if you are just joining up for today, please try to like, share, and subscribe. So all our previous video will be uploaded so that you can watch it and continue with us in our next lesson. Thank you.